All right, welcome back to the podcast. So the first order of business is I remajiggered the name. The new name is The Art of Science because I want to lead with I think the most important bit. People, passion, process is the last part. So a little bit of a rebrand, but I think it's emphasizes that what we're really trying to get on this podcast is sort of the art, both in terms of like I think the intersection of art and science, but mostly like the craft of doing science. And so our guest today is Kate Kennedy, who was my high school physics teacher. And I would say Kate and we talked before this, so you're well aware that I'm trying to embarrass you here a little bit here. But I'd say that one, you helped me fall in love with physics. But two, I think part of that was that we had all these wonderful teachers at Ashland High School in Southern Oregon. But I think you were the teacher that like could always field my questions. Like I remember I just had tons of questions and I would just like ask. I've always asked lots of questions. I think that's why I'm still a scientist to this day. And I remember you would always give me like an answer. It wasn't like you wouldn't just like push me off, be like, go ask somebody else. You would always kind of give me some intuitive answer. And I think that was, I don't know, sort of how I got hooked on physics because I think it's like a very simple framework where you can solve a lot of problems. Like, I think actually my memory got worse when I had started doing physics because I realized you don't need to memorize anything. You need to know like energy is conserved and then everything else is kind of straightforward. Um, So I'm really happy to have you back on the podcast. And yeah, so why don't you just introduce yourself and give a little bit of a background on physics and high school and teaching and all that.
Well, at first I have to tell a little story about Tias, and I've told this many, many times. I'm not sure I've told it to you, but when you were a sophomore and in my regular physics class, you came in one day, might have even been after school. There was nobody else around, and you said, "I don't think I'm smart enough to be a physicist." And
I don't remember that.
you were 14 or 15, and I said, "Tias, you are absolutely smart enough to be a physicist." And I could tell that you were falling in love with the subject, right? And you just didn't know, if you had the chops, right? I think at that time. And those can all be developed. The
Yeah.
passion is so much more important than
Mm.
just the practical ability.
Mm-hmm.
And I had a lot of students who were extremely bright, you among them, but who didn't have maybe the passion for the subject, right? It's a
Mm-hmm.
combination of things that really you need.
Right.
Um, so the
That's
other thing
funny.
that he, yeah, the other thing that he
That's
is, I
lingered
haven't.
with me for my whole career. I still am kind of feeling that way at times.
Well, I think self doubt's always there, right? But
Mm-hmm.
um, I felt that as well a lot of times. But I think physics was just such a way that you could jump in and try to figure things out.
Mm-hmm.
And and I do remember because I had quite a few students in a freshman level class that you didn't take, but then you were a sophomore in my physics class.
Mm-hmm.
And I often had students who had questions about relativity, questions about electricity, questions about the things that I had kind of delved into a little bit and
Mm-hmm.
like to include chaos theory, right?
Mm-hmm.
And I pretended like I knew the answer a lot of the time. Or you could say, I don't know, but here's what we think,
Yeah.
or nobody really. I remember a student crying in class one time during relativity, and they're like, "Aren't you going to explain this to me? I don't understand." And I'm like, "I just did explain it to you, like at the level of my understanding." And yeah.
Yeah.
And I love teaching relativity because some of the really top kids who math was easy for them and they could write well, they would kind of fall apart a little bit,
Yeah.
you know.
Yeah.
And that was just so fun.
Yeah.
And it was so fun to have younger students. I just felt this way that I think, like you probably asked some of those questions to some of your teachers when you were in elementary school and you were in middle
Mm.
school, and they didn't have the tools or the time or the
Right.
reason to give you an answer, right?
Mm-hmm.
So I love those questions, and yeah, we would go off on tangents in class
Yeah.
around some of that, or after class, people would come in, so that was lovely.
I remember we talked about, I think it must have been in just the normal physics class, but I remember like computing masses of, nuclei, and you'd like look on the periodic table at the mass, and we kind of figured out how fission, you know, E equals mc squared and all that. Like,
Yes.
obviously that's the most famous formula, and I still remember like that when I picture being in class, that image comes to mind of like
Yeah.
sitting in your
Oh.
classroom and kind of realizing that like that's where energy is coming from. It's
Right.
like a
Yeah.
mass
So cool.
difference. So
Yeah, I love teaching the nuclear science, and we did it. You did it in physics and did it some in chemistry. My brother is a nuclear engineer, so I even in class we'd call him once in a while and ask him a
that's fun.
question. But it was just nice to be able to delve a little bit deeper. Yeah, and of
Mhm.
course, I think there were a number of things that I taught that were wrong,
Mm,
and you might even feel this way teaching at the university level. It doesn't really matter in some
yeah,
ways. I mean, it's not like we're lying to people, but it is about the passion. This is what we know now. This
yeah.
is what we think happens. You
Mhm.
know, you know.
I
I
think
don't know. Nobody's ever seen an electron. Just gonna
right.
set them on.
Yeah.
But,
That was one of my I want to sort of unpack. I think this is really fun because it's very meta. Now I'm a teacher, and I but kind of new at the game, and you're on the full other end of it. Uh and one of the things that when I first started teaching, I was really concerned about was kind of the classic thing of, oh, what if they ask a question and I don't know? Like, what if you have a student like me,
right.
that just asks a question and you don't know? And I think I realized that one, I usually did know the answer, but even when I didn't, it's okay to like say, hey, this is what I do understand, but this is what I think is an open question or something along those lines. And
Right.
that humility is not a vulnerability as much as it's actually a strength. Like I think I cultivate a different rapport with students by sort of sometimes acknowledging when I don't understand stuff.
Right.
Obviously it's a fine line because they still have to respect you as an instructor, but um, I think a lot of students have imposter syndrome, and there's a lot of mental health stuff. And I think acknowledging that you're, you know, not perfect either is an important tool for teaching as well.
Right. Yeah, I think you were in the first year I taught AP Physics.
I
Is
think
that
so.
what you remember?
Yeah.
Yeah, and I remember in being lost in that class a couple of times. And I think was Galen Lorem. And I remember a couple of he might have been the next, but I remember relying on you and other people. Well, how would you do problem number 5? What happened when you got here? 'Cause
Yeah.
I'd just be totally stuck.
That one was a total grab bag. Maybe we can zoom out a little bit and you can
Mhm.
tell me like your whole path maybe to where we cross paths.
Yeah. Well, I was lucky, like you, to go to a great high school. It was a public high school. It was way bigger than Ashland, but we had a lot of advanced courses and some great instructors. And chemistry, AP chemistry was the toughest class at my high school, had that reputation. And when I took it, there were 6 of us in AP chemistry. This is the
Oh, wow.
2000 student high school. And that teacher, Mr. Garbrick, said to me, Middlebury is the only place for you. That you
Oh,
need to go to
wow.
Middlebury. And he
Wow.
had been there for a language school, interestingly enough. He'd been there for the summer language school.
Mm-hmm.
Um, and so I went up with some girlfriends in the summertime. We did a big tour and looked at a bunch of schools and interviewed at Middlebury.
Huh.
And I was lucky enough to get in, it
Wow.
was great. And,
What do you
you know,
think he saw in you? I mean, because
I know it's so interesting. I think, Middlebury's always had a reputation of being a very outdoorsy school,
Mhm.
athletic. And so I was those things. And I think I did enjoy a liberal, I was after a liberal arts education. I think I had a wide, I loved chemistry, but I had a wide range of interests.
Mhm.
So I think it was some of that. But yeah, it was really interesting. That's a great question. I should have asked him or should ask him.
Yeah.
Kind of lost touch, but
Well, it is a great fit, um, for you and for me. And I guess for context, I went to Middlebury in no small part thanks to you. I think I kind of had no clue where I wanted to go. And
Mhm.
I had looked up in a book. It was like, um, I forget the name of the book, but it was some list of kind of hidden gem schools or something like that. And I had
Right.
a random assortment of schools, some big schools, some liberal arts colleges all over the map. And one of them was Swarthmore, great school, but it was kind of like I just plucked it out of a book.
Mhm.
And I remember I must have been an AP physics then or something, but I knew you had gone to Middlebury and I more or less just swapped the two out
Interesting.
and then got in and had a great financial package and then kind of did a bit more research and it ended up being a perfect place for me. A
Mhm.
little bit of a culture shock at first, but
Mhm.
it was great and the physics department was wonderful. But
Fabulous.
um, yeah, you and I have a lot of connections.
Crossover. You know it. I taught for 30 years at Ashland High School, and I only had 3 students ever go to Middlebury in the 30 years. And you were the first, I think.
Yeah,
But all 3 were physics majors.
yeah, I remember why.
How bizarre is that?
Yeah, it's pretty funny. Yeah,
It's pretty funny.
well, yeah, the
Because
intersection of the Venn diagram is you.
I guess it's very
Yeah.
funny.
Hmm.
But one of my greatest um, things about Middlebury when you were there at TSU had asked me, I told you some things about it,
Mhm.
and what to expect and, what the student pop. And then when you got there, you're like, it's exactly what you said. And this was, 20, 30 years after I had graduated, right?
Mhm.
But, there's some cultural things I think that are there that are probably still there, in the
Yeah.
student body.
Mhm.
And so that was cool. So yeah, I was delighted that you were there and I was delighted that you had such a good experience.
Yeah.
And I kind of knew that you would. So, so
I remember like the first week very vividly. Well, I hadn't visited, so I just showed up cold. And
that's amazing. That's amazing.
I would, it worked out. I wouldn't say it was the best move. But I remember just being so stimulated, like having other smart kids that we could just talk about. And, that same sort of thing carried over into grad school as well. But I remember just like so much happened in the first week because it was like, I finally felt like I was in the right place where I could just chat with anyone about anything really. And it was
Yeah.
full spectrum.
Yeah. Yep. Yeah. My experience there was good. It was great. Because of the AP credits that I had, I took organic as a freshman.
Oh.
And just by happenstance, when I was there, you were randomly assigned a faculty advisor.
Uh-huh.
Or maybe not so randomly. I thought it was kind of random, but every freshman had a faculty advisor. You met with them the first week to go over your schedule and talk about things. And Dr. Harnest, who recently passed away, was a chemistry professor at Middlebury, was my, randomly assigned faculty advisor. And he's like, "Oh, you're going to do organic. You've got the major halfway done."
Mhm.
So it just kind of fell into the chemistry in a way.
Mhm.
Um, I did love it, and I loved it in high school. If I had had a different physics teacher in high school, I probably would have been a physics
Mhm.
major. I took Rich Wolfson's physics class my
Mhm.
sophomore year, but I sat in on his history of the universe, which was such a great class.
Yeah.
Um, and I went to one of those classes even before I was at Middlebury, and I was like, yeah, this is the place.
Yeah.
Um, and with the chemistry major, after organic, most of my classes were like 6 or 8. I had classes of 2,
Mhm.
uh,
Wow.
where you don't not do the homework or not
Oh
show up to
yeah.
class or,
Gotta be accountable.
got to be accountable. So it was tough. But just that deep level of understanding was so good.
Mm.
But your experience might be similar in that over the course of my life, it's some of the other classes that I really refer back to.
Yeah.
A political science class I had that was fabulous,
Mhm.
psychology. Um, I took an anatomy and physiology class through the dance department at
Oh,
Middlebury.
interesting.
That
Huh.
was all about, here's this muscle and here's how it moves, move this way, move that way. So
Uh-huh.
it just, You know, we used the anatomy coloring book, like you learned a whole bunch of stuff, but it was
Yeah.
not from a memorize this kind of way. It was
Uh-huh.
how does this feel? And so,
Huh.
you know, as kind of an athlete my whole life, you know, you've just
Mhm.
referred back to that, you know?
Yeah.
So that was a
So
great class.
that's a cool
Uh,
tool.
yeah.
But you were creative writing minor.
I was a creative writing minor. You know, writing has always been much more challenging for me than math and science. I'm not a great speller.
Mm.
Um, I'm better, you know, I was better. It's funny as I'm aging, I'm finding that coming back. It's very
Huh.
interesting. But I've, you know, I've worked on it and learned tricks to make it work. But now
Mhm.
every once in a while I'll just have a blank as to how to
Mhm.
kind of spell something. It's funny
Yeah.
how that works. But I just really knew I needed more writing.
Mm.
And besides the creative writing, I took a lot of classes through the English department, poetry, you know, English literature, Russian literature. You know, there was a lot of writing, but it
So
was
you did it
painful.
to intentionally round your skill set out.
Yes, I did. I
Oh,
did it intentionally. Yes.
that's I think a rare approach. Most people
Yeah.
just stick to what they're good at, right?
Yeah. I think, but when you're in a place where people are good at a lot of things, you know, not
Mhm.
everyone there is good at everything, but you know, so many of my friends, you know, my freshman year were American lit majors and English
Yeah.
majors, right?
Yeah.
I mean, I was a little bit of an oddity,
Mm.
um, right?
Yeah.
Being, you know, you know, math and science. Actually to take classes with some of my friends, you
Yeah.
know, to take,
That's funny.
you know, American art or, you know, wilderness in the American mind or, you know, some of
Mm.
that kind of stuff. And of course, winter term was a great opportunity to do some different things.
Yeah.
And to study some different things. And so
Huh.
I think, you know, and I think you do get to round your skill sets out, which help you as you look for work, regardless of what that is, right?
Yeah. Yeah.
And you also just get all these tools for life as you continue on, you know?
Yeah.
So,
Yeah. My wife gives me a sort of joking hard time because I took for the wrong reasons. It wasn't for friends in the class, but I needed to just check off that distributive requirement. But I took an Asian art history and Asian religions class.
interesting.
And we'll go to art museums and we'll go into the, Asian section. And I'm like, oh yeah, I could see the earlobes on that Buddha. It's because, blah, blah, blah. And I just pull stuff out of nowhere. It's like, it's just funny how that works. I think, as you said, some of my most memorable classes were the ones that were just like way outside of my comfort
Right.
zone.
And then the ones that I missed, right? Like during my time, Middlebury offered a really great I don't know what to call it, a music appreciation class, history of
Mm.
music.
Mhm.
I don't know anything about classical music, right?
Mhm.
And that, you know, I wished I had taken that, right? There
Mhm.
was a great religion class and a great religion professor, comparative religions,
Mm.
that I didn't get to fit in, you know. So,
Mhm.
just because I know what I got out of you know, like you, I had two classes in like American art, and
Mhm.
so, and art of the wilderness,
Ooh,
and so
that's fun.
then when I go to an art museum often,
Mm.
that's where
Huh.
I'll go often.
Yeah.
But it does. It just gives you an appreciation for so many different things. I took some theater. I took a couple theater classes,
Oh, cool.
and more of it wasn't performance based. It was reading plays,
Huh. Okay.
and the development of theater over time, which was great. So yeah,
It
it's
helps with your Oregon Shakespeare Festival work.
totally. It's true. It's true.
That's funny. Well,
But then
oh, yeah, go ahead.
you know, after Middlebury, you know, I grew up on Long Island, and so Middlebury was rural to me, and I loved it. And then I just kind of got more and more rural, you know, and ended up in Montana and Wyoming,
Mm.
Northern California. And so finally I decided, you know, it's probably time to get a real job,
Mhm.
um, and went to the local college here, SOU, just to get my teaching certification. And
Mhm.
I'd done some substitute teaching before I had a certification, and I just enjoyed it more than I thought I would. You know, I never really wanted to be a educator. It didn't. I don't know. You're too close to it or whatever. But
Yeah.
once I started teaching, I just really enjoyed it. I really enjoyed it. and I taught my first year in the Dalles. And I taught 6 sections of freshman physical science
Okay.
in the basement with no windows. And the teacher who taught chemistry and physics said he would resign before he ever taught freshmen again. And I
Wow.
just suggested they give him that opportunity. Um,
That's funny.
but then Ashland, there was a job open in Ashland, and I applied for it. And when they wanted to interview me, I knew I had a spot.
Hmm.
And I more recently learned that there was a mother, Jean Crawford, on the interview committee, and she was from the East Coast. And she's the one who said, we want to see this person. And because of my Middlebury degree.
Interesting.
Right. She went
When
to
you know, you know.
I know, right.
Yeah.
And nobody else cared really, I guess.
Yeah.
But came down, had a great interview, and I was the first science teacher they'd hired in 22 years
Wow.
at Ashland High School. So it wasn't that you couldn't get a job in Ashland; they didn't exist. Right?
Yeah.
So people
Yeah.
came and stayed, and of course, I was the first female science teacher. But then, within a short period of time, helped recruit, and hire.
Yeah.
Most of the people that we.
Yeah.
Becky DeSalvo came from Colorado, and similarly, she'd gone to Mount Holyoke. Even though she was from San Diego, but she had a lot of other world experiences.
Yeah.
So she was a great hire and still there, and a fabulous teacher. So we had some great ones, and people who were just really dedicated.
Yeah.
So
Yeah, I remember wanting to. It kind of started high school. I think pre-med made sense. It was like, oh, I'm smart, so go be a doctor. And I think the physics and then B. Carlson's math kind of finally made sense. Oh, yes. And the combination of the two, I was like, well, I guess I just got to follow this. And I never really looked back. But I've been kind of pondering this myself, but like, what is a passion for teaching? Like, what do you think that comes from? Where does that come from? Like, what really got you out of the bed? I mean, there's obviously days that are harder than others, but like, I honestly can't put a finger on it myself, other than that I like to talk. But like, I enjoy watching people learn.
Well, and I think you learn so much.
Yeah.
You don't really learn until you teach.
Mm-hmm.
You don't really. I mean, I like to learn things, but then I like to understand things at a more visceral level. I think that's why physics is so good, right? And like with even electricity, when you dig in and kind of get a more simplistic, visceral kind of understanding, whether it's truly what's going on or not, but I don't know, but it can explain so much of the phenomena we see and so much of the equipment that we use and build, right? That you just get a kind of this gut level understanding of how that works. And then fixing a lamp is not a mystery,
Right.
right? So I think for me, it was really about learning. It was about sharing, things that you were passionate. Of course, you love those light bulb moments. You love trying to turn kids on,
Yeah.
and you just, I loved education. It got harder, but my first 3 years in Ashland, I had 100 students in 5 classes.
No.
Before I retired, I had 180 students in 7 classes.
Wow.
And that's just, it's so hard. I'm not as funny, I'm not as relaxed.
Yeah.
It's harder to do labs, right? Which was my whole jam, right? Was really getting people to do things and getting.
Yeah, I was just thinking about that when you were talking about sort of having the intuition, because what's interesting is I feel like I more and more rely on that. It's like you're like growing this tree, and what I like about physics is that, again, you don't have to memorize things, but what's left is this distilled, like very concentrated intuition.
Right.
And I think a lot of that comes from labs. And I remember you pushed a lot of labs in all your classes. And so I mean, was that something you were like taught to do, or did it just sort of come naturally?
I don't know. That's a good question. I mean, I think at Middlebury, certainly I had tremendous labs
Right.
and, in high school, some, yes, some, yeah. And I had a great AP biology teacher and we did a lot of lab work,
Mhm.
chemistry, some, physics, not so much in that at the high school level, or at least maybe that I remember.
Yeah.
Um, but definitely at Middlebury. And I think those are the things you look back upon and remember.
Mhm.
And you just learn by doing. And I
Yeah.
think, kids struggling, such a good thing.
Mhm.
And in physics and AP physics, you have kids who are very intellectual usually. You have a lot of
Mhm.
kids who they know a lot of stuff, they can do a lot of stuff. And then you throw something at them, in a group where and you don't help very much, those are
Mhm.
the best.
Yeah.
I used to think my best lessons when I could go take a nap,
Yeah.
because all the work is done beforehand and they're just,
Yeah.
even that, I don't know if even the stuff we did with the motion detectors, the really old
Mhm.
school,
I remember those things.
where kids are looking at velocity and acceleration graphs and trying to
Yeah.
figure out what a flat line on an acceleration graph
Yeah.
means. And they're all pointing at the screen and talking to each other, trying to move
Mhm.
to make it. And I mean,
Mhm.
those were just the best.
Yeah.
And there's
It's
yeah,
it's funny, like, when I first started teaching, I was so excited to try to just give them as much material as I could.
yeah,
And so we have, they're called X hours, but it's like an extra class time that some some professors use, some don't, but it's a separate, it's not supposed to be formally lecture, but I would just, it's partly what I inherited, but we would just lecture through all. And
yeah,
I'm like, oh, just
yes,
give them as much stuff as possible. And this a subset of them just like feel all of it and they go with it.
yes,
Most don't.
yes,
And
yeah,
the more I've taught, the more I'm like, you know, push it back on them. Like finish this derivation in small groups and somebody come up and show me. And on the one hand, it's lazy teaching, but on the other hand, it's effective teaching.
yeah. I don't think it's lazy. I don't think it's lazy. I remember different teachers would say, they would want their prep period at the end of the day,
Mhm.
because they're tired or not as effective at the end of the day. So they want to, and I always wanted a first period prep
Mm.
because I wanted to have everything ready. And,
Mhm.
almost all my work was before class. And if it was
Mhm.
really set up well, you let it go,
Mhm.
you, everything you needed was there. And,
Mhm.
even at the end of the day, the kids are more tired at the end of the day, so that can be
Yeah.
harder, but, they rise to the challenge,
What do you think
especially if
was
you
your
give them something involved to do, right?
right? What do you think was your biggest like transformation over the course of your teaching career? I mean, class size, like there are
Yeah.
external
Oh,
factors,
I
but
see.
how did the way you
You
teach
internally.
change?
Yeah, it's a good question. I mean, one of the things, early on, and you experienced this, is that I started my classes with a poem, right?
Oh, I remember that.
Yeah,
Yeah.
and so, that happened maybe 1st or 2nd year, and I don't even know why I began it, but it was
Mhm.
just kind of a way the bell rang, just
Hmm.
start with a poem, discuss it, sometimes not, they were chose mostly for length, you know?
Mhm. Mhm.
I didn't think too much about it. At the beginning, I just had a drawer full of these random pieces of paper, right?
Mhm.
I'd pull one out, um, and I think what I did notice with that and some other couple of other things I did in chemistry too, is that it was so nice to address other parts of students' brains,
Mm.
and like
Mhm.
in chemistry, we did a project where students made a square for the periodic table. Everybody got an element, and then
Mhm.
they didn't really learn that much from that. They learned some about but they were displayed. But those kids who were good at art, those art kids, they could shine,
Yeah.
and everybody, they had free reign. They could do whatever they wanted and display it. Um, there were other ways and other things where the used to teach a little bit of organic nomenclature in chemistry just because there were some kids who just really got that, and the
Mhm.
mathy
Mhm.
kids sometimes didn't.
Yeah. Yeah.
And so that was okay. So I
Mm.
think I think with science, it's really nice to be able to pull in those other learning modalities, but really just to let other strengths show. If you
Yeah.
have if you ever have a project where a kid can write some music or a student can, read something that they've written or, and, dress something and draw, I mean, I was big drawer when in physics, you can bring
Yeah.
that in. And so even if it doesn't get points, on a test or whatever, students still feel like
Yeah.
they can show you that they can do something,
Yeah.
well, and it's something they're maybe passionate about or good at. So,
Yeah.
so that was something I learned. That was something I learned. And the poetry was a part of that. I'm talking about books, talking about vocabulary. We just come up with a weird word. It's like, what? That is such a cool word. Where's that mean,
Yeah.
Um, so, and I think some of that comes from a liberal arts education
Yeah.
too. Just so interested in everything.
Yeah. I think
And
I appreciate it more and more now. Because around the time of high school, I sort of decided I'm a math physics person, right? And then I think there's this perception that these things are like mutually exclusive.
yes,
And I kind of like went that direction and leaned into it. But it's funny now because most of my job, I would say, is reading and writing. And
Yeah.
if you don't prepare for that, it can blindside you. So, I mean, we both clearly appreciate liberal arts educations, but maybe you can explain a little bit about principles of technology and sort of,
Yeah.
because it doesn't work for everyone. I don't think everyone should necessarily have, a liberal arts degree, for instance, but
Yeah. Well, I taught at Ashland. I started teaching chemistry and physics, and of course, I was a chemistry major. And then the physics teacher had retired, and the chemistry teacher was retiring. Harry Wright, who'd been there forever. And I had a choice of either going all chemistry or staying with more physics. And I chose physics because I was learning more. Really, I mean, I love teaching chemistry, but
yeah.
physics, I was just, understanding and learning so much more.
Hmm.
And so there was this course called Principles of Technology that was developed in conjunction with some big government grants. I think it came out of Texas. I should know CORD, CORD. I don't know what that stands for. That's something that sticks out in my mind,
Okay.
but it was really a course developed for students going into more tech schools. And it was like, this is the physics you need to know if you're going to be a mechanic, if you're going to be, an airplane mechanic, if you're going to do any of that kind of stuff. There was math embedded in the course. It was at an algebra level. It was taught in a very applied way, kind of for kids who have more of a difficulty with math, I think. But that's when we brought it to Ashland, that's not really how it was, that's not how it was taught. It could be taught that way, but it was a great class for freshmen. I loved teaching that class. We had 9th through 12th graders in there. So you had the freshmen who were so excited, and we would talk about relativity even in there.
Wow.
Their brains would blow up, right? And then you had the senior who needed another science credit to graduate, who would spend all their time in the metal shop. So I had a really wide range of students in there, which was really fun.
That's cool.
Freshmen were usually only about a quarter to a third of that class. And that was great. And it was very, very hands-on, very lab-based. And, water troughs and flow rates.
Yeah.
And what was so interesting about that class was that it taught things separately. So it was really a brilliant way of teaching electricity because you looked at force and you looked at mechanical force, fluid force, voltage, right? And then you looked at work and rate, mechanical rates, fluid rates, gallons per minute, cubic feet per second, and then current, right?
Huh.
And then you looked at resistance,
Very
friction,
symbiotic.
right? And you so you didn't put Ohm's law into it until like the 5th unit or 4th unit, right? But by that point, you had a pretty visceral understanding of what voltage was, it was the pusher, right? And what current was.
Yeah.
And when I taught it in physics kind of all together the first couple of times, people were forever confused, which is which, what's the I stand for again, all that stuff. Where here you gave a piece at a time and then brought it together. So it was a much slower way of teaching it, but it was embedded in everything else, right?
Yeah.
And then this, the circuit tables,
Yeah.
you had the power supplies and you had the light bulbs and you had, you know, series and parallels to, it wasn't anything fancy really, but
Yeah.
you really did get kind of this gut level understanding of what was going on
Huh.
as you compared it to other things.
That's so
And
interesting.
it was such an interesting class. And then of course it was just the algebra, and some basic equations,
Right.
and building off that and pulleys and levers and
Hmm.
it was
That's funny because I feel like I try to emulate that a lot in my classes. I feel like we have a very short. We're quarter system, so
yes
we say 10-week term, but it's really 9, and
yes
it moves fast, and
totally
I think um I spend a lot of time. The beginning is a little bit rushed because you want to like get some of the concepts out there, but I feel like I had class before this, and it's kind of one of those classes where you can go slowly again because you've sort of built enough of the foundation. And all I was doing really is connecting dots of things that we had already done.
right.
And it's really satisfying to sort of end. So the latter half of my courses, in some sense, it's like review, but
Mhm.
you're not like introducing new things. It's more like reinforcing the connections between those things.
Yeah,
And it's just such a satisfying way to end because
yes,
that's kind of, I think, the thing that you leave a course with is
right.
being able to do any of the problems even, or know the jargon. Like all of that stuff is gone, especially for our quick terms. Like they just cram and then forget everything. uh,
Mhm, mhm.
but they remember that intuition, and they remember those connections and these physical examples, and
Right, right.
it's just a really useful way to do it. And it's not, I find, like, I'm teaching quantum mechanics, and most books, it's like they just start with like the postulates of quantum mechanics. Like, here are these things that are sort of like the 10 commandments, and then like learn what the math means, and then we can do the rest of the stuff. And I hate doing it that way
Mhm,
because
mhm.
you're just like pulling stuff out of thin air.
Right.
So instead I start with like the Stern Gerlach experiment, and I actually start with like picture the classic atom, and explain why like that just can't possibly be how the world works, because that thing is accelerating and will spit out light, and then nothing would exist.
Right,
Um,
right,
or-
right. So
so
cool.
I don't know. It's Intuition is everything for me, and I
Mhm.
trace a lot of that back to like how I learned physics from you, actually. So, um, yeah, it's
Well, it's so good to have like a constructivist approach, right?
Mhm.
Can they construct stuff? Can they put it together themselves?
Mhm.
Um, and those light bulb moments that everyone talks about is really when kids are connecting those dots, right? So
Mhm.
they're doing it. You've kind of
Mhm.
led them in that direction, but they're going, oh,
Yeah.
I see how they.
Sometimes I even force them to build these like concept maps. So you like have
Yeah,
nodes,
yes,
ideas, and then draw that in. And it's like, if it wasn't obvious before, it's like we're actually like making a visualization of how I want you to like think about all these different things.
yeah,
Uh,
yeah. That's awesome.
the denser those networks get, the more you understand, as far
The
as I can
better.
tell.
Yeah,
So,
yeah.
well, this has been really fun. You know, uh, it's been really cool to kind of grow out of high school and stay in touch over the years, and
It's been
I know
wonderful.
it's been a really special journey. So thank you for everything that you've done for me, and um, yeah, it's been really fun. Um, so I guess I'm gonna start a new initiative. I want to end the episode with just some books that either you're reading or you think other people should read. Um,
Awesome.
and yeah, whatever comes to mind for you.
Yeah, yeah. I'm actually in 2 book clubs, which is one too many, right? But you do get, I get exposed to things that I never would have read. So interestingly, I read In Cold Blood by Truman
Ooh.
Capote, which I had never read. And it's dark, but
Uh-huh.
so good. So fascinating. We had a great discussion about it. It was really good.
Huh.
I just finished a book called The Water Remembers by Amy Bowers Cordalis, who is a Yurok Native American and a lawyer. It's the history of her family and the undamming of the Klamath River here.
Oh.
And it's very good. It's recently out. I highly recommend it. The return of the salmon to the Klamath has been amazing.
Yeah, I heard they bounced back almost like instantly.
It's amazing, and we'll see what happens as we go on. But I went to a Trouts Unlimited meeting just a few nights ago with my husband and learned that at the Keno Dam, because there still are 2 dams, but they have fish ladders. But the Keno Dam last fall, they had 2,200 salmon go up that
Wow.
ladder, where there were 0 for
Wow.
100 years before that, because the fish
That's
couldn't even
crazy.
get there. So, and
Wow.
some of those fish continued almost 100 kilometers beyond that into the
Wow.
Upper Sprague River. So, I
That's
mean, it's,
amazing.
yeah, that's amazing. So that's just the first year. So they're doing a bunch of restoration work. It's very cool.
Yeah,
But I highly
fish
recommend
can
that.
bounce back. I don't know, I was watching some like Planet Earth with Leo, my son, and
Yes.
it was usually it's a lot of kind of depressing things about species collapse and stuff. But there was one example, I forget which fish, but they kind of just stopped overfishing in some region, and like the fish population bounced back like tremendously.
Right.
It's kind of amazing how quickly they.
Well, I
I
think
don't know if that's
Earth
all species,
bounces.
but fish.
Yeah, I think the Earth bounces back, you know? I mean, there's some really good evidence about ozone depletion in the atmosphere, which was a big thing. I mean, when I was at Middlebury, acid rain was a huge thing.
Oh wow. Huh.
And the acidification of lakes, and what was going on. And, you know, there was a smoking gun determined in Tacoma when the
Hmm.
when the big smelting factory in Tacoma shut down, and they had some clear evidence. And so really that problem has changed a lot because of our behavioral change, you know.
Yeah.
So it's still possible. It's still possible.
Yeah.
So that's hopeful. So that's
Well,
a
that's a good optimistic place to end. So,
Yeah.
Kate, thank you so much for being on the podcast. They means a lot to me. And thanks for inspiring me when I was. It's hard to even picture being in that age, but long time ago.
It was a long time ago, but
Yeah.
it was great. It was an honor. It was a real honor.
So
And,
thanks a lot.
thanks for having me, Tias, and
Yeah.
I'll talk to you soon, I hope.
All right. Thanks a lot. Bye.
Yep.